So, all right, let's try this now. So, here's our tornado. It's rotating counterclockwise. And let's say it's rotating counterclockwise at a speed of 120 knots. So, forgive me for the seasickness, but let me set this down here. And it's rotating with a speed of 120 knots. All right? 120 knots. And it's traveling east at a motion of 20 knots. All right? So what we have, the tornado is rotating at a speed of 120 knots, and it's traveling east at a speed of 20 knots. Where will the winds be the strongest, and how fast will they be? Where will the weakest winds be, and how fast? Well, if we do what we just did, if you notice on the south side of the tornado, the wind is blowing in the same direction that the tornado is moving in. In part one of the tornado, the wind is blowing in the same direction that the tornado is moving in. What would you do in that case? You would add the wind to the forward motion. So you would add that 120 to the 20. And so your total wind speed there would be 140 knots. So it would be 140 knots. All right. Now, where would the winds be the weakest in this case? It would be up at the top on the northern side. Why? Because there the wind is traveling in the opposite direction of the storm's forward motion. So in this case, what would we do? We'd subtract. Yes, we would subtract. And so what's 120 minus 20 in this case? 100. 120 minus 20 is 100. So again, at the bottom, the wind is traveling in the same direction that the tornado is traveling in. That's 140 knots. At the top, the wind is traveling in the opposite direction that the storm is moving in. So there you subtract the two. That is 100 knots. All right? And if those of you watching on the video still need help, please feel free to email me. All right? Bye.